Hi, I'm Jim Berg. I'm a hydrogeologist with the Minnesota Department of Natural Resources. I've worked on a study that was funded by the Legislative Citizen Commission on Minnesota Resources, using money from the Minnesota Environment and Natural Resources Trust Fund. This study was designed to learn important details about the physical characteristics and the groundwater recharge of the Mount Simon Aquifer. The data from our recent study lets us see this underground aquifer in some new ways. On this image, the extent of the Mount Simon Aquifer is shown in blue, with outlines of Minnesota counties shown in green. Although not shown on this image, the aquifer extends into neighboring Wisconsin to the east and Iowa to the south. The area between the pink line, which is the western and northern edge of the Mount Simon Aquifer, and the brown line is the recharge edge of the aquifer. The dots show the locations of monitoring well clusters or nests that were installed by the project. This flyover view illustrates key groundwater recharge areas at the western edge of the Mount Simon Aquifer. These edges are important because surface water that seeps into the ground in these areas flows to the Mount Simon Aquifer. In the area northwest of the Twin Cities metropolitan area, in Wright, Sherburne, and Isanti counties, the western edge of the Mount Simon Aquifer is relatively shallow at approximately 100 to 200 feet below the surface. This western shallow edge of the aquifer is covered by porous sand and gravel that allows water to pass easily into the Mount Simon Aquifer at some locations. To the east, hundreds of feet of aquifers and aquitards separate the Mount Simon Aquifer from any surface water in the center of the metropolitan area. Data collected and analyzed for this project show that some modern water is penetrating to the top of the Mount Simon Aquifer. When this new information is added to previous studies, it's even more clear that this area northwest of the Twin Cities is the only place where rain and melting snow can recharge the Mount Simon Aquifer within the span of a human lifetime. Shown in a cross-section with ages indicated, you can see how groundwater has traveled for at least 10,000 years to the aquifer that's now beneath the Twin Cities metropolitan area. The main recharge area for groundwater in the Mount Simon Aquifer is in parts of Wright, Sherburne, and Isanti counties. The sandy soil beneath the forests, wetlands, pastures, and croplands allow for at least moderate replenishment of groundwater. But if local communities aren't careful about what they do on the land surface in this area, they risk contaminating the waters that seep down to refill this important drinking water supply. By mapping the data we collected on aquifer water levels, we were able to see how use of the Mount Simon groundwater is affecting the levels of water in the aquifer. When a well pumps water from an aquifer, the water level near the well lowers in the shape of a cone, and water in the aquifer flows toward this low spot. When there are multiple wells pumping, a regional zone of lower groundwater levels can form. This downward trend in groundwater levels is also shown in data that have been collected in Scott County since 1984. When water levels are mapped from many wells like this, the depression in water levels can be seen on paper or in 3 dimensions. The water level elevations are shown here as a 3-dimensional surface. The greenish areas represent the higher water levels, while the reddish areas show lower levels. Over the past 30 to 40 years, we have seen a decrease in the water levels toward the center of the St. Paul and Minneapolis area. In pre-settlement times, the water level surface of the Mount Simon Aquifer probably looked like a smooth version of the land surface, similar to the surface shown here. But over time, the lower groundwater levels beneath the Twin Cities are the result of continuous high-volume pumping by dozens of production wells in the metropolitan area for municipal and industrial use. Groundwater levels in the center of this zone of depression have dropped more than 200 feet since the time that European development started in this area. The blue circles in this view show the locations of Mount Simon groundwater users, and the size of the circle is proportional to the amount of groundwater used per year. In 2010, the combined use of Mount Simon groundwater was 14 billion gallons per year in this area, an amount that does not appear to be sustainable for long into the future. 75% of this use is by municipal waterworks, followed by 16% industrial processing, including petroleum, chemical, and agricultural uses. These new data will help community leaders respond to two concerns for this major water supply aquifer: protecting the resource from pollution and conserving it for future generations. There are key areas within certain counties that play essential roles in replenishing water to the Mount Simon aquifer: northwestern Wright County, eastern Sherburne County, and southern Isanti County. Because we now know how important these water recharge areas are for the Mount Simon aquifer, protecting them from water pollution should be a high priority for all levels of government. This research and previous U.S. Geological Survey studies have shown that in the Twin Cities area, we are pumping groundwater out of the Mount Simon aquifer faster than it can be replenished. More work is needed to better compare the amount of water moving into the aquifer to the amount being taken out. This will help us understand how much pumping is sustainable for household and business use without depleting groundwater supplies. Our long-term economic vitality depends on an adequate supply of high-quality water. We need to take steps to protect this aquifer from pollution and overuse, so it's available for future generations. Discussion questions. How can you and your community conserve water? What land use decisions can you make to protect your drinking water supply?